Alright, so today's lesson is going to be about measurement and different ways that you can teach measurement. So before we get specific about some of these things, I want you to take out some of the handouts, specifically this one, okay? And I just want you to know that, at first, it is less intimidating if you're teaching younger students to maybe have them measure with other things other than like traditional measuring tools. So notice you can use your white C-rods. Now remember, this is white or tan, but if for most of you who made your own C-rods, it's probably white, okay? So you could have them measure their hand with these different items, okay? You could have them measure the foot with different items as well. And then the benefit to this is actually that, just so you know, these are actually 1 centimeter. If you take out your manipulative set, the C-rods, the smallest measurement of C-rods, the white ones are actually 1 centimeters. You also would have gotten square tiles in your manipulative set, and those are actually 1 inch. So it's kind of a less intimidating way of figuring out how much measurement different items are. So just so you know, a paper clip is a little more than 1 inch. Okay, but the point is that to have them measure with non-traditional measuring tools, okay, and then of course ruler and inches and centimeters and millimeters, things like that would be more appropriate once they start to be able to use things like that. So you could start with, again, non-traditional tools like anything, okay. You could have them measure in marshmallows if you had them, okay, but it's just a matter of them counting and learning how to measure things based on a count. Okay, so you can turn this over. There's some activities that you could maybe use in your classroom. Okay, we're not going to actually do these, but I would want you to be familiar with these processes. Okay, in other words, that measurement doesn't always have to be with traditional measuring cups or measuring tape or rulers or whatever unit we happen to be using. You can use non-traditional measurements as well. Okay. Okay, but let's look at our number system, or the number system used across the world. Now, interestingly, the U.S. uses a number system that most of the world doesn't use. Most of the world uses the metric system. Okay, so pretty much everyone but us uses this measuring system. Okay, and then we use what's called U.S. customary. And like the name implies, it's used in the U.S. Okay, but just so you know, you need to know both and our students need to know both. Okay, with as global as our world is now, the companies that they work for, even when they get to high school, they're going to definitely need to know how to do both. Okay, so we can measure some different things, and we're going to go over some of the basic units of measurement for these things. So we can measure length. Okay, that's probably the first thing you would teach your students to measure. We can measure in feet, in inches, in yards. We can measure in meters, etc. Okay, just so you know, inches, feet, and yards are U.S. customary measurements. Meters is the metric system. Okay, you can measure weight of things. You can go ounces or pounds, which is the U.S. customary measurements for weight, or you can go grams, which is the metric measurement for weight. You can also measure volume. So we have lots of measurements for volume in the U.S. customary system, like lots. Okay, little t stands for teaspoon, capital T stands for tablespoons. But you can have cups, you can have pints, you can have quarts, you can have gallons, you can even have fluid ounces, which is not the same ounces as the weight measurement. Okay, if you've ever cooked something, they say you're not supposed to use, like the dry measuring cup is different than the liquid measuring cup. Okay, but then again, the metric measurement of volume is liter, okay, or a version of liter anyway. But we can also measure time. Okay, and that's certainly something we teach our elementary students, right? So we have seconds, minutes, hours, days, weeks, months, years. Okay, now notice there's not a US versus metric measurement for time. The measurement for time is pretty standard across the world. So notice that if you will look at your handout, I gave you a lot of these measurements, okay, or a lot of these conversion rates, I should say. Okay, so notice in the US customary system, there's inches, yards, miles. Okay, for weight, there's pounds and tons. Okay, so a ton is 2,000 pounds. For time, we have all of these, right? For volume, all the things that I mentioned. Okay. And then the metric system, the reason it is beneficial and powerful, and most people that are in science anyways think that the US needs to change this measuring system, is because it's a base 10 system, okay? So the base unit for length is meter, the base unit for weight is gram, the base unit for volume is liter, and then you add all these prefixes that mean different powers of 10. So kilo means 1,000 base units, so a kilogram is 1,000 grams. A kilometer is 1,000 meters, okay? The prefix hecto means 100 of the base units, so a hectometer is 100 meters. A hectoliter is 100 liters, okay, and so on and so forth. So if you can learn what these prefixes mean, then putting this prefix in front of any of these base units means the same thing. So deca means 10. So if I ask you what a decagram is, that would be 10 grams. If I ask you what a decameter is, it would be 10 meters, okay? Notice that for deca, I'm pointing to where I want you to look right here. Notice we use DA to abbreviate deca because deci means 1/10, and we can't use D for both of those. So just keep that in mind. That might be a little unnatural for you to write DA, but that is what the abbreviation is. So then when we get to partials of the base unit, we go deca, centa, milli, okay? So for deca, decimeters, deciliters, decigrams, it takes 10 of those to equal 1 base unit. So notice these are smaller, right? It takes, instead of being multiple base units equals some of these up here, these are taking multiple of the partial units to equal 1 whole, okay? There is 100 centas in a whole, so there's 100 centimeters in a meter, and so on and so forth. There's 1,000 milligrams in a gram, okay? So notice with a little bit of knowledge, you can actually represent lots of different measurements. Okay, and again, a lot of people think we should be in the metric system since our number system is base 10. Okay, this actually goes by place value, so it's actually a little more helpful as opposed to, let's look up here at the US system. Do you see how all the conversions are very different? Okay, so it's a little bit challenging, to be honest, to even remember these. Like when I'm cooking, sometimes I have to look up some of these things. I don't know these all at once, okay, because 2 cups equals 1 pint. 2 pints equals 1 quart, but then 4 quarts equals a gallon, okay? So some of them I remember better than others, okay? And if I, as an adult, struggle to memorize those, then our students do too, okay? As opposed to the metric system, where you could memorize some prefixes and some base words, and then you would know any measurement that you could be asked to find. Okay. Also notice on here there's some formulas that we talked about last week. I just decided to put this on the same worksheet just so you could have kind of all of that together. Okay, so let's talk about how we're going to do conversions, how I'm going to want you to show your work, etc. Okay, so there's a good rule of thumb. If you were going from big to little, in other words, a bigger measurement to a smaller one, you are going to multiply. And if you're going from little to big, you're going to divide. This is a challenge for our students to remember, just to be honest, okay? So you might have to work with them on this for a while. All right, so let's look at a few problems in the US customary system. And let me show you the kind of work I'm going to want to see on your homework and then also on your test. Okay, so let's say that I gave you these problems. So I just want you to write these down and then we'll try to figure them out. So 1 feet equals how many inches? 3 pounds equals how many ounces? 4 gallons equals how many quarts? Okay, so notice you would want to refer back to this page to figure out the conversion rate. Okay, in other words, I started with one I felt like you should know already. So there are 12 inches in a foot, right? Notice we are going from a big measurement to a smaller one. Feet are longer than inches. Okay, so if we want to go from this to this, we will multiply by however many inches there are in a foot, which in this case is 12. Okay, so this will just be 12 inches. But notice from pounds to ounces, again, bigger measurement to smaller measurement, right? So again, I'll be multiplying. So look back at your chart here, okay? So how many ounces are in a pound? Remember, this is weight, not the liquid measurement, right? So there are 16 ounces in 1 pound. So you're going to be referring to this sheet quite a bit, okay? So we're going to multiply. So you would multiply times 16, so that would give you 48 ounces. Okay, gallons to quarts. Gallons are, again, bigger than quarts, so we would multiply. So look on your list and notice that there are 4 quarts in a gallon, so I'm going to multiply by 4. Okay, so anytime you know you're going from a bigger measurement to a smaller one, you will definitely want to teach your students to multiply. Okay, notice that will require that they know things like that gallons are bigger than quarts. Okay, so that's a little bit of a challenge. Again, that's something that you don't run into with the metric system, because if they learn the prefixes, then they know which ones are bigger. Okay, I'm not really a proponent for us switching our measurement system, but I can certainly see why people want to. All right, so let's look at these. Again, these are with the U.S. Sometimes you'll see tablespoons with a capital T, or sometimes it'll be like TB and then TP for teaspoons. So notice here I'm asking you to go from smaller measurement. Inches are smaller than feet. Okay, so not only will you need to look at your chart, but you'll need to remember that when I'm going from little to big, I divide. So I would divide by 12 here, okay, or I would get 5 feet. It also stands to reason that 60 inches should be less feet, right? Because a foot is a much larger measurement. 12 hours is how many days, right? So we would divide by 24. So we'd end up getting 12 divided by 24, which reduces to a half a day. Okay, and then last but not least, smaller measurement, right? Tablespoon's certainly smaller than a cup. Okay, so you would have to look back at your list and notice there are 16 tablespoons in a cup. So if we divide by 16, we're going to get 2 cups. Okay, so there's certainly some things you shouldn't take for granted that you should teach your students, you know, that might require a little bit more thought process. Let's look at a couple where maybe we have to go kind of across multiple measurements. So when this happens, what you'll need to do is something like this, okay? So I know I can look at my list and find out that 1 mile equals a certain number of feet. And then I know I can do 1 foot equals a certain number of inches. And then maybe I can transfer that into how many miles it takes to get to inches. Okay, so let's take these for instance. Notice I'm going from bigger measurement to smaller, right? So I'm going to multiply by 5,280. Notice there's just a 1 here, so that's not too challenging, right? One bigger measurement to a smaller, so I'm multiplying again. 1 foot is 12 inches. Okay, so let's see if we can come up with a conversion here. Okay, so 2 miles, okay, is going to equal a certain amount of feet, and then is going to equal a certain amount of inches. So in other words, instead of trying to go straight for it, I'm just going to use my information up here. Okay, so notice I would multiply by 5,280, right? And that's going to get me to 10,560 feet. And then I want to go feet to inches, right? So then I would need to multiply by 12 here. And if you do that, you'll get 126,720 inches. Okay, and notice that's my answer, right? So I'll go ahead and circle that. So when you have to kind of jump across measurements like this, then I would want to see all of your work. I would definitely want to see this line that I starred, okay? If not, the work up there so that you could see which measurements you needed to list. So let's do some more like that. So what if I asked you to go from gallons to cups? Notice I don't have that on your conversion sheet, right? But I can list all the information that I think would be helpful. I can go from gallons to quarts. And then I can mention how many pints are in a quart. And then finally, how many cups are in a pint. So this is the part that I want to see. So if I want 3 gallons, I have to go in stages. I have to change it to quarts, change it to pints, and then finally I can change it to cups. Okay. Notice in all of these measurements I am going from bigger to smaller, so I will be multiplying always. Okay. So to go from gallons to quarts, I multiply by 4. So that's going to leave me with a 12. To go from quarts to pints, I need to multiply by 2. So that's going to give me 24. And then to go from pints to cups, I need to multiply also by 2. So that'll give me 48. And notice this would be my answer, right? Okay, so I don't want you just to go straight without thinking about it a little bit. All right, what about this one? What if I asked you to go from tablespoons to pints? Again, if you notice that the conversion rate's not on your sheet, okay, then that's telling you you're going to need to go in stages. So if you look at your sheet, it does mention how many tablespoons are in a cup. And there are 16. And then it also measures or mentions that there are 2 cups in 1 pint. Notice here we're going from smaller to bigger, so that means we've got something else to think about here. So I've got 160 tablespoons. So first I'm going to change that to cups, and then I'm going to change that to pints. Okay. Notice since I'm going from smaller to bigger that I need to divide. So to go from 160 tablespoons to how many cups, I would divide by 16. Okay, that's going to leave 10. And then from here to here, we would divide by 2, so that would be 5. So in the end, the answer would be 5 pints. All right, so we've looked at just about every type of measurement, right? We've looked at a couple of lengths. We've looked at some volume, okay? But we haven't really looked at time yet, so let's do one with time. This is one that we're probably a little more comfortable with, if we're honest, because we all know time pretty well. All right, so notice if I want to go straight from weeks to hours, I know that 1 week is 7 days. And I know that 1 day is 24 hours. So if I want to go from weeks to hours, there should be an R there, then I need to talk about days as well. All right, notice I'm going from longer measurement to not as long, right? Bigger to smaller, so I will be multiplying. So there are 7 days in a week, so I would multiply there. That would give me 21. There are 24 hours in a day, so I'll multiply by 24. And so in the end, I get 504 hours, and that's my answer. All All right, so we certainly need to teach our students the U.S. customary system because that's the measurement system that the U.S. uses. Okay, that's the one that they're going to run into a lot. But in fields of science and even for certain books that are maybe written in different countries, okay, and I don't mean different languages, I mean like written in England or something, they are also going to need to be aware of metric conversions, especially when they get to junior high science. Okay, so this is a good rule of thumb here. I'm going to use the abbreviations. So the biggest one that we usually talk about, there are bigger, are the kilo. That stands for, K stands for kilo, and then it's hecto, and then remember what I said about deca, it's DA. And then in the middle is going to be what we call the base unit. So the base is always either meters or grams or liters. And then as you go smaller, we have deci, centa, and milli. So for everything this side of the base, we're going to multiply by 10. Think of it like we're going from bigger to smaller, so bigger to little. So if you start here, these are always bigger, okay? But if you're starting here and going this way, notice this would be smaller to bigger, okay? So here we would divide by 10. So frankly, these are easier to manage because all you have to do is kind of count how many place values away you are. So we won't really need to do as many of these examples. So we'll do a few of these. So what if I asked you to change kilometers to hectometers? Okay, and maybe we've never heard of a hectometer. Okay, I get it. That's kind of a weird one. I picked that one on purpose. Okay, so notice if you look at your list though, how many stages away we are. Okay, so a kilometer is 10 away from, or a multiple, one multiple of 10, right? So we're just going to multiply by 10 to the first power. Okay, and we're multiplying again because we're going from larger measurement to smaller. So in the end we get 230 hectometers. Okay, notice there's never a need to go by stages here. You just need to ask yourself how many measurements away we are. Okay, by the way, we usually use a capital L to abbreviate liters, not a lowercase l. So we just need to ask ourselves how many decimal places away we are. Okay, so notice we are, if you start here, we are 1, 2, 3, 4 decimal places away. So, by the way, we are still going from bigger to smaller. So when you decide what you're going to multiply by 10 to the fourth. Okay. In other words, you're going to move the decimal place 4 places to the right. Okay. If we're multiplying, we're going to move it to the right. So your answer is going to end up being 24 with 4 zeros on the end. Okay. Or 240,000 deciliters. Okay. So 24 kiloliters equals 240,000 deciliters. All right, let's make sure we know how to go backwards. Okay, so first make sure you know how to say that. That would be centigrams, right? Because we're talking about G for grams. So if I asked you how many grams this was, so again, you need to come up to your list and see how far away we are. Now we're going backwards, all right? So we are only, notice, 1, 2 spots away. So because I'm going smaller to bigger, I'm going to divide. So I'm going to divide by 10 to the 2 power, or just divide by 100. Another way is we can think of it like we're just going to move the decimal place twice. Okay, so notice that would put us at 400. So there's certainly some things to memorize in the metric conversion system, but notice if they know this, okay, and you know this, then actually we're just going to either multiply or divide by powers of 10. So it's actually pretty relatively easy. There is a lot more to memorize with the U.S. customary system. Okay, the point is that I will want you to be able to do both, and you will need to be able to at least mention both at some stage because students are going to see both no matter what. All right, so for your email activity this week, I want you to email me the answer to example 5, okay? And you can just email that to my email address.